Hi, this is Mr. Adams from Midwood High School, and this is a video on the equilibrium constant K, also called the mass action expression. We did this in class, right? And this is a brief review, because this will be on our test on April 8th. Now, this is a simple concept. It's just showing us at equilibrium which direction the reaction is favored based on the values. And before we can plug values in, we must know how to set it up. Now, in the equilibrium constant expression, the products are always over the reactants. Okay, so if you have your reaction here, and these colored circles represent the products because they're on the right side of the arrow, and these guys represent their reactants, you'll notice that the products are always, okay, on the top. All right. And in terms of the coefficients, you notice that the coefficient right here for C and D for the products, right, are represented as exponents. Okay, so once again, the products are always above the reactants, and the coefficients are presented as exponents. Now, we must also take into consideration, guys, the fact that pure solids and liquids are not considered in the equilibrium constant expression or the mass action expression. So if we have a particular reaction and there's a pure solid S in it, or pure liquid L in it, we do not take into consideration. But if there's aqueous or gas, we take those guys into consideration. Now, in terms of questions on the test or quizzes or whatever, you can actually also be given K value or K expression, all right, K expression, and ask what reaction did it come from. So once you can do one, you can do the other. So we're going to do today, we're just going to look at how to set up the expression, and then afterwards, on the test or quiz, you should be able to figure out which reaction it came from. Okay, and as we said before, the larger your K value, okay, it indicates that your products are favored, or the reaction is moving towards the right. If your K value is very small, it means that you're favoring reactants, or to the left side. If you have a K value of 1, okay, then you have equal concentrations or equal amounts of products and reactants. Now, in your textbook and in other readings when you move on in chemistry, AP chemistry in college, you'll see terms like KSP, okay, you'll see terms like KP, which is partial pressure for gas, all right, and terms like that. So don't panic if you see those terms, KSP, KP, KC, for example. Are they all referring to the same concept of the equilibrium? And if your equilibrium value is large, it moves towards the right. All right, as always, you'll pause the video, okay, and you'll do this problem right here. Simply set up the equilibrium expression. We're not going to plug any values in. We're just going to work on setting it up, okay? And do this one also. This is a combustion reaction. Set up the expression for this reaction, and we'll see how you do. Okay, we're looking at carbon reacting with carbon dioxide to produce carbon monoxide, 2 moles of carbon monoxide. Now, before we do anything else, we must make sure that we take the phases into consideration. Now, remember that solids, right? We don't use them. Okay, so solids are not used in the expression. So we see that we have gas and gas, so we'll use those two guys. And we remember that K in our expression is always going to be equal to products, which is CO in this case. Now the square bracket refers to concentration. Okay, guys? So the square bracket, we put a square bracket around it. So there's a concentration of carbon monoxide, and we put it to the second power because our coefficient is 2, so we put a 2 right there. All right? And that's the product side. And in the bottom, in the denominator, we will put CO2, okay, in square brackets. All right? And we don't need to put any coefficient because if you have a 1, okay, as your coefficient, we don't have to put any exponent. So there's nothing goes there, and that's it. You're done. Okay, we move on. And in this expression, this combustion reaction, okay, we take into consideration the phases once again. So we notice we have a gas, 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 and a liquid. Okay, so liquids, they're not considered. So we'll be considering these three guys right here. And we see that CO2 is our product, so that will be going in the top of our K expression. So K will be equal to CO2 square bracket to the fourth power. All right? And the H2O got ignored because it's pure liquid. We put our denominator divider there. We put C2H6 square bracket. And in front of the C2H6, we notice we have a 2. You see we put a 2 there. Okay? And we put another square bracket right here. Okay? Inside goes O2. And in front of the O2, we notice there's a 7 coefficient. So that 7 coefficient goes as a 7 exponent, and you're done. Okay? These two square brackets together, it's going to be a multiplication. Okay, we're multiplying there, so never addition goes there. Okay, so these two operations will be in the bottom will be a multiplication there, and we'll divide those guys into the CO2 at the top. Okay, so there you go. Okay, guys, this is a very brief video on the equilibrium constant. Okay, if the K is large, your products are favored. If it's very, very small, your reactants are favored. I hope this video was a help. As always, hard work plus sacrifice equals success, and take care.